This is the video for Mod 6, Lesson 5, Solving for Missing Sides with Trigonometry. The goal of this section is going to be applying our trig ratios we learned from the previous section to solve for a missing side. So when we do this, the first part is going to look very similar to what we did with solving with or setting up ratios. So we're first going to identify the acute angle or the angle they give us that we're going to be using for solving. And we're going to label the sides in relation to the opposite, the hypotenuse, and the adjacent. And we're going to mark our diagram. We're then going to set up a ratio using sine, cosine, or tangent, and then use that ratio to solve for a missing side. So in this example, just to walk through the setup, and we're going to see a couple different setups. So we're still using SOHCAHTOA, so sine, cosine, and tangent. The goal, though, notice, isn't just a ratio, it's solving for x. So we're going to first take the angle they gave us. In this case, they gave us 63 degrees. And we're labeling everything in relation to that 63-degree angle. So we still have our hypotenuse, we have our opposite, and we have our adjacent. What's a little different, though, is we identify what we're trying to solve. We're trying to solve for x, which is our opposite side. They give us the hypotenuse, which is 14, and they didn't give us the adjacent for this one. So when I look at my trig ratio, I'm looking for an opposite and a hypotenuse, and the trig ratio that pairs up with is going to be sine. And so that's basically step 1 and 2 is just labeling and then picking the ratio that would go with that. We're now going to go ahead and set up a fraction. So I know the sine of 63 degrees, which is some number, is going to be x over 14. All right, so this is the part that we've kind of been practicing with. Now we're going to go ahead and have to use our calculator to help us out with the rest. In our calculator, we want to make sure our calculator is set to degrees because there's actually 2 different ways to calculate. And you're going to notice these buttons, the sine, the cosine, and the tangent. So what happens is our calculator actually knows the ratios for every single angle. So not just 30, 60, 90, and 45, 45, 90. It knows like 50, 40, 90 triangles. It knows 63, 40, or 63 and 27 degree and 90 degree triangles. So it knows every right triangle combination you can come up with. So when we do sine of 63 in our calculator, you can see it actually gives us the value of what that ratio is. It tells us it's 0.891 and then a whole bunch of digits after, 006 and so forth. So what we can do is we can do a few things. We can put that in our calculator and replace it or substitute, or we can treat our when we solve, we can keep it as sine of 63 and just evaluate at the end. Either one's going to end up working out. And then usually it's probably best though to round at the very end. So sine of 63 is just a number. I'm going to go ahead and put a 1 underneath it because I could write it as a fraction, knowing that sine of 63 isn't 63, but it's this long decimal expansion that we see on the right. So now I'm going to do the same thing we did with similarity. I'm going to go ahead and cross multiply. X times 1 is x. I'm now going to do 14 times the sine of 63. Notice I'm not doing 63 times 14. Sine of 63 is something very different. It's those digits, like I said, that you see on the right. So in our calculator, we can actually even type in 14 times and then sine of 63, and that would give us our final answer, and that actually ends up being, if I do 2 decimal places, 12.47. So what that means is the length of the side is actually 12.47 units. And then that would be the answer to my problem. If I had to find the second side that was missing, I could do Pythagorean theorem, I could do trig again. I kind of have a lot of options of what I can do. For examples 1 and 2, it's actually the exact same process. So you identify the angle they give you. for all of these, we're using SOHCAHTOA, or sine, cosine, and tangent. We can't use Pythagorean theorem or special right triangles, so we have to use trigonometry. If I go ahead and label this out, my hypotenuse is across from my right angle. If I trace the angle, this is my adjacent leg, this is my opposite leg, and you can see the x and the 18 is your adjacent and hypotenuse, and that's going to go with cosine. So our ratio we're going to do here now is the cosine of 71 degrees, which again isn't 71, it's that if you put in your calculator, you'll get a long decimal. Adjacent is x, hypotenuse is 18. And so my setup for this problem would be cosine of 71 is x over 18. And then we're going to go ahead and cross multiply. So I'm going to solve for x. We get x is equal to 18 times the cosine of 71. And when I put that all in my calculator, you should get 17.21. If you put this in correctly and you're like, you're getting the different answer, it might be your calculator's in the wrong setting. So you want to make sure your calculator's set to degrees. For the next example, same thing. I can't use any of my other methods of solving besides trig. So this is my opposite side. This is my adjacent side. This is my hypotenuse. If I look what I have here, I have opposite and adjacent. So for this one, I'm actually going to have to use tangent. So the tangent of 47 is 18 over x. And I have to do a little bit of more solving for this one. So I'm going to put a 1 underneath. I'm going to cross multiply. Notice the x isn't by itself. X is actually being multiplied by tangent 47, which again isn't 47, it's just a decimal. I'm going to divide both sides by that value, just like how you would with any linear equation. I'm going to get that value by itself. So 18 divided by tangent of 47 is actually going to end up being 16.79. So the length of that side is 16.79 units. For the last example, a lot of different ways you can do this problem. It's basically solving all the remaining sides and angles. So I'm going to go ahead and just solve for x and y. You can use Pythagorean theorem once you get one of the sides. I'm going to use trig for both just so you can see more examples with trig. But again, lots of ways to do this last problem. So I'm going to take this 23-degree angle and label everything out. So this is my hypotenuse, my opposite, my adjacent. I'm still using SOHCAHTOA. And so you might notice you have lots of variables here. I'm just going to write them all out, and we'll kind of see where we go from here, because this is lots of different ways to do this problem. So you might find that sine of 23 is going to give you y over x, which doesn't really help us with this problem, right? There's too many variables. So I know I'm not going to use sine at all for this problem because there's too much going on. If I do cosine of 23 is 19 over x. And if I was to do tangent of 23, you would have y over 19. So I could actually use trig if I want to solve for both of these. I don't have to. But again, I'm going to show both with trig just so you can kind of see the example. Or get you more practice with it. So if I solve for x here, I have x times cosine of 23 is 19. I'm now going to divide by cosine of 23. And for x, when I do that, I'm actually going to get 19.55. Now I can use Pythagorean theorem if I want to finish solving it. I'm just going to, like I said, use trig, but you can use either one. If I was to go ahead and solve for y, this one I would cross multiply. So y is equal to 19 times the tangent of 23. Y, we get 8.07. So I'd get 8.07. And then the last piece this was asking for was b. I don't have to do any type of trig to find b. This adds up to 180 degrees, right? So if I was to go ahead and subtract from 180, I got a 90-degree angle, I got a 23-degree angle. We're going to get that to be 67 degrees. So that would be all the missing pieces. If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-tries completed to receive full points. So again, the remaining problems from this section need to be completed, even if they're not perfect. We need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.